So just a very basic question that at this point you should all know the answer. But essentially, the number one question when customers call up, they have an application, they want a solution, and they want to know what shaker system should they use. And one of the questions they have is, why does my shaker have multiple force ratings? And would lead us to the product line, and we have a very simple diagram that shows all the products, and every shaker needs an amplifier, so you can combine the shakers with different amplifiers in order to find out the best system. And depending on that combination, you're going to have different force ratings or force capabilities. And a very typical example here is when you look at our 2075E shaker. Those are the two system combinations that we offer. The first one on the left, it's just the shaker and the smart amp. And there's no need for cooling. You can go up to 40 pounds force. And even if you try to put more gain on the amplifier is not powerful enough to drive the shaker beyond 40 pounds force. And the shaker is still doing pretty well there. The shaker gets hot, but still not too hot. So you can deal without cooling, just the natural air cooling, just the air that naturally flows through the shaker is enough to keep the shaker running. On the second system, on your right side, then we use an amplifier that has twice as much power, so you can drive the shaker twice as much, so you kind of almost double the force rating there. And for that particular system, it comes automatically. We add a nice blower. Just to highlight my friends in Italy, it's a nice blower made in Milano, and we buy that blower from the Italians and we integrate with the system, and that allows the system to run all the way up to 75 pounds force. So nothing really much new here. So let's start going to some more technical information. For example, frequency range. People look at shakers and they can run at different frequency points. And if you ask just what's the maximum frequency, the short answer would be just look on the data sheet again. That same data sheet that had the shaker family also has a table listing all the frequencies. So we just specify the maximum frequency for each shaker, and just trying to understand where that number comes from. Then we'll go to our next slide, where I look into one of the frequency response curves that we take for every shaker that we make. We mount an accelerometer on top of the shaker, and we run a sine sweep all the way from typically 5 hertz to 10,000 hertz. And in this particular case, you're going to see a behavior that no matter what shaker you choose from us, you're going to see a behavior where the shaker is shaking, and when it goes up to about a few thousand hertz, it goes through a peak, a resonance peak of the armature, and then it goes down pretty fast. And if I kept measuring higher than 6,500, that curve will continue all the way down. So essentially, when you look at, if you go back to the previous slide and you see the 2075E shaker, that shaker is specified up to 65,000 hertz. I'm sorry, 6,500 hertz, which is a little after the resonance peak. So back to the beginning, shakers they have a force rating. So all it says here is, the shaker can still provide, adequate force or the force that is specified around that frequency point. And it's really not like if you think, most of us also sell accelerometers, you want the accelerometer to be flat all the way through, and that's how we define the frequency response of the accelerometer. On a shaker, you want to get force output. So we really don't care too much the fact that there is an amplification here, there is a resonance here. It just tells me, I don't need to put a lot of voltage on the amplifier input to get that shaker response. And since a lot of shakers are also used with some sort of controller behind them, you'll be in a good shape to go around those peaks and get the output you want. The other way to look at the frequency response, it's also, there's an ISO standard, the 5344, that gives you a guideline. You look at that resonance peak, you take 1.5 times that frequency, and that gives you a good idea of the operational frequency range of the shaker. Well, the other thing is, can I go beyond that point? Yes, I can. I can take that same shaker and go even higher than 6,500. It's just that after that, the force output will drop, and I can have, force dropouts, and I won't be able to get much energy out of the shaker. And the other thing to remember is that curve was taken with nothing on top of the shaker, so there's no payload. So once I add things to my shaker, of course, that added mass will reduce the usable frequency range. So just going back to the shaker curve, if I apply the ISO recommendation and multiply 1.5, I will get a number about 7,800. So basically, our specification is a little bit conservative, and that shaker, will work pretty good up to almost 8,000 hertz. But we use a more conservative spec because not all shakers are made equal. There's a little variance between them. So we just on the safe side here. And if you guys want to know more about shakers, there's a lot of people out there. They try to take the shaker apart and create a mathematical model. I'm not going to go into that detail, but just want to highlight, we talked about the high frequency operational range of the shaker. But when you look at the low frequency side, all the shakers can really go down all the way down to 1 hertz, even down to 0. And 0 hertz means just like, if I apply a DC signal to the shaker, the armature will move up. If I apply a negative voltage to the shaker, the armature will go down. So the shaker can go all the way down to 0. It will not happen in practice because most amplifiers are AC coupled. So you're actually driving the shaker with an AC signal that, maybe a few tenths of a hertz all the way up to normally 2,000 hertz or a few thousand hertz. Okay, and then moving on, this is probably the most common question that we get all the time, and the most difficult one to answer as well. What's the shaker maximum payload? I want to test something. I have a shaker, and what's how much stuff can I put on top of my shaker? And to answer that question, first we have to understand what do I mean by payload, and just using the picture on that slide, payload is basically the total, the sum of my my test article mass and any type of fixturing that I have to attach my test article to the shaker. So this picture, I have a shock data recorder. It's a piece of electronics, and I have a platform base that's basically an adapter to match the shaker to the test article. So that's my payload. And we also have to remember when we are shaking something, the shaker also has to shake itself. So for every shaker, there is we specify the armature mass. So the total mass, the total moving mass will be the armature mass, the mass of the test article, plus the mass of the fixture. And the other very important thing to remember is, what type of application are we talking about? Because, if we're talking about model testing, then, it's not, that's not that complicated because, usually in model testing, your test article is in a free condition, will be normally suspended or sitting on air rides. So the size of the test article is not critical. So what we're really talking about here is in a general vibration testing, in a vibration control testing, where the test article is not self-supported. So I'll be mounting my test article directly on top of the shaker. Just to highlight here, there's also a section on our website you can pick, and we'll guide you through the main questions you have to ask your customers. And I try to explain that using a very simple, very simple set of pictures that I did last night. And if you look at those three pictures, what I'm trying to communicate here is that you don't really need to know much about the shaker itself. It's just, it's a lot of good sense. Without looking at any numbers, at any specifications, just looking at picture number 1, I have my shaker there. I have a little test article on top of it. So, chances are, that's a very good situation. That's a very common situation, very similar to what we had on the customer application picture before. If you look on picture 2, I have a different test article, probably about the same size, not much different, but the geometry is completely different. And what you notice there, it's I no longer have that symmetry I had on the first picture, which tells me the center of mass, it's a little bit off compared to the center axis of the shaker. So what happens, even though the test article is not too heavy, when the shaker moves up and down, that off center of the center of gravity, that mass multiplied by the distance between that point and the center line of the shaker will cause a moment. And that moment acts as a side load on the shaker armature, and that can give me trouble. So the more I demand from that shaker in terms of acceleration, the higher that moment will be. And there are some guidelines on the user manual that tells you gives you some recommendation on how big that moment can be. But as a general rule, you don't want that. If whatever possible, you want to make sure you center your payload, you put your test article in the middle of the shaker. And the last picture, number 3, if you just look at that picture, again, we also have the off-center issue, and you start looking at the test article, and it starts to become too big and too large. So the thing to pay attention here is, if I have my shaker, anything that starts to become larger than the shaker is probably too big. And if something is too big, it's also too heavy, usually, unless I'm putting a pillow or something very with a very low density. But for the most part, something large is also something heavy. So those are the 3 things to keep in mind. And okay, and the other thing, how does the payload affect the stroke? So just another picture here. Every time you add something to the shaker, you are pushing the shaker armature down. So the only way the shaker can react to that additional payload, is by supporting it with the suspension. So we design the shakers the platform shakers, we designed them with a higher stiffness suspension. So in this particular case, for the 2075E, I have a shaker that has a 60 pounds force per inches, and translating that, it's 10.5 newtons per millimeter. So we are talking about, let's say, about if I put like a 1 kilogram, is that right, on top of the shaker, that will be about 10 newtons. So that will push my armature down about 1 millimeter. So essentially, if I put something too heavy, that will push my shaker all the way down until the shaker goes to the bottom, until the armature goes to its limit, and essentially, I'm not able to shake anymore. I can only go up, but I cannot go down. So if I'm doing a vibration testing, I need to be able to go up and down. But that's why you have to watch out how heavy is the article you put on top of the shaker. And then, going back to Newton's law, so the primary question, which is, what shaker should I use? Again, we're going to look at the total mass that it's going on top of the shaker, and add the armature mass, the test article mass, any fixture mass, add them up, multiply by the acceleration that I'm trying to reach, and make sure that number is less than the force rating of the shaker. And just remembering, the other thing to make sure we check is the displacement, because as you go lower in frequency, we know that it's going to be easier to reach the maximum mechanical displacement of the shaker. So I just a quick review here. We all know that displacement, velocity, and acceleration are interrelated. And there is an equation at the bottom that allows you to calculate that. I'm putting together a spreadsheet just to make it easier for you guys to do that calculation. Or, there's also some references on the internet how to do that. But I don't want anybody to spend much time doing mathematics here. All I want to emphasize is what we call the payload curves. And the payload curves is just a very easy and graphical representation of those equations we just looked at. When you see the payload curve, there's like it's like a platform and a ramp. So the ramp piece of it is dictated by the relationship between displacement, acceleration, and frequency. So this is the line of constant displacement. So since I have a shaker that's 1 inch peak to peak, if I plot that in a logarithm piece of paper, I get a straight line. And the top piece of the graph is my maximum acceleration, which basically is F equals ma. So if I apply Newton's second law to the 2075E shaker, I know just by default that shaker has an armature that's about half a kilo or 1 pound, and just that shaker can produce up to 75 pounds force if I have the big system. So 75 divided by 1, I don't need a calculator, is 75 Gs. So that line here sits exactly at the 75 G acceleration level. And as I start adding things on top of the shaker, I will have, like if I add like something that's about half a kilo or 1 pound, I will have I still have the same 75 pounds force available. 75 divided by 2 is 37 and a half. So as I put more things on top of the shaker, you notice that the acceleration curve starts going down. So it's very intuitive. The things I put more on the shaker is kind of pushing down the curve, just like with what we saw before. And the last curve that I have here, if I have something that's about 5 pounds, and that will put my shaker down to up to 12.5 G's peak. And what I also try to accomplish on those curves is to show you as we putting things on top of the shaker, the fact that you're pushing the armature down, you're losing a little bit of the initial available displacement that you have. So the shaker was 1 inch peak to peak, but as I put a 5 pounds mass or test article on top of it, I'm losing. I still have the same force, but I can't. I have less acceleration available and also less displacement available. So keeping those things in mind, always look at the curves. The curves are published on our website, and the useful area that I can use that shaker. It's under the curve. And for each shaker system, we have a curve like that. And so just, I think I mentioned that already. We look at the suspension stiffness of the shaker, so we can calculate the effects of the payload on the stroke and do all that calculation. But again, I don't want to spend too much time on calculation and blah blah blah. So just looking at just a general rule of thumb, if you have the 75-pound shaker, you can only go up. We say on the website, we say on the literature that you can test an article that's about 3 kilograms or 7 pounds. So that again is a general guideline. It's not it's not you can always go a little higher, a little below. We always have to remember what we saw before. Pay attention at the size and the shape of my payload. Make sure it's symmetric, make sure it's balanced on top of the shaker, make sure it's not too heavy, and make sure it's not too much larger than the shaker. And if we pay attention to that, we just do a quick calculation just as a sanity check, and we should be good to go. So I'm running out of time here. So just not out of questions. I mean, there are many more questions that that we have answered and we continue to get. But just the final question of the day, and all the shakers, if you noticed, they have a little piece of foam on top of them. So what is that foam? What is that for? Why we have a foam on top of the shaker? And the answer is the foam, as you see here between the shaker top and the body of the shaker, it's just there to protect the shaker. It's some people call that a filter because it lets the air flow, allowing for natural air cooling, but it doesn't let dust and other things and particles to fall into the shaker, which can definitely be a big issue, especially if those particles are magnetic, or and that can get into the shaker gap, and over many cycles even damage the shaker. So we put that piece of foam there. It protects the shaker. Some people have complained in the past, oh, that foam is fragile, it can cut or tear apart. And well, I mean, if that happens, it's an easily replaceable part. We'll provide a new foam. And so far, people have been careful, and we haven't had a case yet of the foam being damaged. But it will eventually wear out, and we will eventually get dirty. So customers, the manual explains you can clean it up with a vacuum, or you can even remove that from the shaker, wash it with water, and put it back on the shaker, and you have a clean foam for many, many years to use. And that was all I had for today.